was that rock basically? That was
Magnetite.
magnetite. Okay, but now we call this as magnet. Basically, we obtain magnet out of it. Okay.
Yes.
All right. Then we learn about some of the uses of magnets, right? Their magnets
Yes.
comes in different shapes and sizes, and we have magnetic and non-magnetic materials. We did learn about this, and we were learning about the poles of magnets. Okay, now, so from
Yes.
here we're going to continue. Let me just fill my cup of water, and then we're going to continue. Okay.
Okay.
All right. So talking about the poles of magnet. So we learned in the previous class that there's a very interesting property about the magnets, when we try to attract the iron fillings to a magnet, like this bar-shaped magnet. Hmm. So we observe, or like apart from this bar magnet, we can take a horseshoe magnet also. Okay, now of this shape, we could have taken that one also. So what we observe that what we'll be observing that the iron fillings will be getting all they will be always accumulating at the ends of the magnet. They'll be always accumulating at the ends of the
Yes.
magnet because the poles of the magnetism because near the poles the magnetic field of the magnet is very strong. Near the poles, near the ends, the force of attraction of magnet is very strong. So these ends where the force of attraction is very strong, that is called as poles. Got this now? That is the thing. So the question is, what is magnetic field? But first of all, get to know about this thing. Okay, na? Poles of magnet. Okay, like write down the definition for it. Give the topic poles of magnet. Yes, Salman is here. Yes, Salman. Assalamu alaikum. How are you?
Yes. Walaikum salam wa rahmatullahi wa barakatuh.
All right. So poles, we observe that at the ends of the magnet of the magnet, the force of attraction or repulsion is greatest, and they are called as poles. They are called as poles. They are called as poles. Who let me know once you guys are done writing this. By the way, Salman, when did you told me your exam is going to be?
September 24.
24 September. Okay, okay. Yeah. Done writing this?
No, sir. Sir, repulsion
Uh,
spelling is Repulsion, right?
Sion. Yeah.
Okay.
Repulsion. Yeah. Yes, Salman, you were saying something? See,
I'm
guys, do
writing.
writing it now. Okay, okay. Okay.
Sir, after repulsion,
Repulsion
repulsion
is
is
greatest,
okay.
and they are called as poles. At the ends of the magnets, the force of attraction or repulsion is greatest, and they are called as poles.
Done, sir.
Both of you.
Yes, sir.
Good. Next, we are going to learn about magnetic field. So, magnetic field will be basically an area around the magnet along in which within which the magnetic force will be acting. I mean to say that, let us say take the example of this diagram here. Like this much is the region in which the magnetic field is acting, magnetic force is acting. Meaning that if I were to place an iron nail over here, this will not be getting attracted to the magnet because I have placed it outside this region. I haven't placed it within this region. Getting it now? But if
Yes,
I were to place it here now, at this place, now it will be getting attracted towards the magnet because it is within this field, and in
magnetic field.
within this magnetic field in which the magnetic force of attraction will be acting upon this iron nail, right? Also being
Yes,
strongest at the poles now, since this magnetic field is strongest, so the magnetic objects will be getting attracted towards the end of the magnet, towards the poles. Getting my point?
yes.
So it will be getting attracted towards the pole. So that is the case of the magnetic field, that we'll be defining it in the following manner, that it is magnetic field. Give the topic magnetic field. It is defined as the region around a magnet, around a magnet within which the magnetic force acts. Okay. Furthermore, write down that it is strongest at the poles. Magnetic field is strongest at the poles. So that is why magnetic objects get attracted towards the ends of the magnet. Write down this much only.
Sir, magnet within the word.
Within which the magnetic force acts. It is defined as the region around a magnet within which WHICH the magnetic force acts, and it is strongest at the poles.
Sir, I'm done.
Done? Okay, both of you?
Yes, sir. I
Good,
finish.
good. Now we are going to learn about how using magnets we can find the directions. Okay, now so this is one of the great property of a magnet, that it can prove extremely helpful in finding the directions, in navigating the directions. Right now, because the thing is now, if I were to take a freely suspended magnet, it will always point in the north-south direction. Meaning that, for example, I hope I had a thread somewhere here. Anyways, just try to understand it in this manner. Let's say I were to take a piece of magnet here, and if I were to freely suspend it with a thread, let's say I have tied it with the thread, so it will be always aligning itself in the north south direction of the earth. Like This is our Earth. This is the
Yes,
North Pole,
sir.
and this is the South Pole of the Earth, right? So if I were to take a magnet now, like you have taken, let's say this is a piece of magnet in my hand. Okay, both of you. A piece of magnet. And if I were to tie it with a thread, if I were to tie it with a thread and I'm holding it like this, so it will always point in the north-south direction. It will align itself in the north-south direction. Meaning
Yes.
that I mean to say it like this. There's a magnet like this. You have tied it with a thread and you're holding this thread. So you're holding this thread. Okay, now. So it will align itself in the north-south direction like this.
Yes.
In the north-south direction. In this manner, it will be
Sir,
aligned.
it's like a bar thing.
Bar magnet.
Bar
This is a
magnet.
bar magnet. Bar shaped magnet. Okay, na? So thereby it will be very helpful now. Like we can get to know like in which direction the north is, in which direction the south is. So thereby we
Yes.
can navigate on the earth. Particularly, it was helpful for the sailors. Huh?
Yeah.
And this property is used to make a compass. This property is used to make a compass. Like there's a magnetic needle, like this structure where I'm pointing. This is called as the needle of a compass, and this is magnetic. So this is a magnetic needle. Meanwhile, you guys give the topic of finding direction. Okay, now?
Sir, the needle is only the magnet.
Yeah, needle is made out of a magnet. It contains magnetic
Oh.
property. Okay, now? So a magnetic needle is placed inside this box with directions marked on it. North, south, east, west directions have been marked on it. And it is allowed to move freely, meaning that like this can move freely like this. Okay, now it can move freely. It is not fixed.
Yes.
Just like how the hands of the clock, it can move freely. It is
Yes.
not tightly fixed. No? So it can move freely. Got the thing. So it can
Yes, sir.
move freely so that when the compass is kept at the position of rest, and like you are not shaking the compass, you're not moving it. So just keep it stable. So the needle will always point towards the north and the south direction. The needle, when you keep it in the rest direction, in the rest now, like when you keep it at a position of rest, it will never be pointing towards the west and east direction. Not like this. It will always be pointing in the north-south direction. Getting it now? And thereby, with the help of this, sailors in the sea can find in which direction the north is. Right? So that is the thing. Hope you guys have understood this. If it's clear, please let me know.
Yes, sir.
Yes.
That is the thing. Okay. Now you might be wondering like why the magnets always aligns in the north-south direction in the earth. A very basic question one should think of. One should be thinking of this. What is the reason behind that? See, the reason
It's because of the
because of the earth.
sir. It's because of the atmosphere.
Atmosphere. Complete the sentence. Because our earth also behaves as a giant bar magnet. Our earth also behaves as a giant, a huge bar magnet at its center. Getting what I'm trying to say? Like if you were to look at the earth now, like the earth also behaves as a giant piece of magnet. For example, let me draw, it is this one. So here, this is the north pole of the earth. And this is the south pole of the earth. Now the thing is that at its center, our earth also behaves as a giant piece of magnet. So thereby it will be behaving as a giant piece of magnet in the following manner. This is the south pole of the magnet. As you guys know, like a magnet has two poles now, namely south pole and the north pole, right? Poles of a magnet are the south pole and the north pole, right, Salman and Halima?
Yes, sir.
In the same manner, this magnet, like our earth at its center, also behaves as a huge bar magnet, but the poles are opposite. Like this one is south pole and this one is the north pole of the earth's magnet, and they are opposite to the geographical north and south pole. Like this is the actual geographical the north pole of the earth and this is the geographical south pole. Getting my point, both of you? So it is opposite to that. Both of you turn your cameras on in the class,
Sir?
by the way. Yes.
So, can you repeat? There was some internet issue, so
Okay, no issue.
so it by mistakenly got left.
No issue, no issue. See, basically, I see it now. Like our Earth also behaves as a giant bar magnet. Okay, na? At the center, our Earth would be also behaving as a giant piece of magnet. So this is the south pole of the Earth's magnet, and this is the north pole of the Earth's magnet. Getting it? Like, just think of a huge bar magnet, and now imagine it running through the Earth, going into the Earth. Hmm? One end is entering into the north pole, another end is in the south pole here. Hmm? Getting it? So the end of the magnet that is in the north pole, that is the south pole, and that end of the magnet which is towards the south pole, that is actually north pole of the magnet. Getting the thing? And we know that
Yes, sir.
thus this
Yes.
magnet, the needle of the magnetic compass, it always points towards the north south direction. Why is it so? It always points, this needle always is pointing in the north direction. Actually the reason is now, suppose you are holding this before that now, there's one more thing you should know, that how the magnets interact. Like as we know that when two magnets which are having unlike charges, which are having opposite charges, meaning the not charges, opposite poles, I mean to say, like this one is north, this one is south. So when magnets with opposite poles are brought together, so there's a force of attraction between them. They get attracted towards each other. As you can see, it is demarcated by these arrows. So these magnets gets pulled towards each other. But when like poles, like south poles, when they are brought close to each other, so a force of repulsion takes place between them. Both of
Sir,
them will be
even
repelling each other.
north pole also be like
Exactly. Even if were to be like this, you have the north pole here and you have the south pole here, and you brought another magnet with the north pole here and the south pole. So they will also be repelling each other. They will move away from each other. That is one thing.
yes.
So basically, what we can conclude here that unlike poles,
Sir, should be right.
no, just one. Later on, you will be writing it now. Unlike poles attract each other, while like poles repel each other.
Repel it.
Repel each other. That is something both of you have learned. Now
Yes.
get back to this. Now imagine you are holding this piece of magnet over here. Just let me take one image of this. Just 1 minute. Now better. So imagine you are holding a piece of magnet standing on the earth, and it has been it is in a position of rest. So it is pointing in the north south direction. Why is it so?
Yes.
Because the thing here is now, because the thing here is that 1 minute. Because the thing here is that this here is the north pole of the magnet, and this here is the south pole of the magnet. And what we know that opposite poles attract each other, right? This is north
Yes.
pole of the magnetic compass, and this is the south pole of the earth. So north and south, they will be attracting each other. Getting it? Salman, you getting it? Halima, you getting it?
Yes.
And
Yes,
this
sir.
one being south, this one being north, so they will be getting attracted towards each other. That is the reason why this needle will always be pointing towards, will be always aligning itself in the north south direction. Not just needle, not just this needle of the magnetic compass. You can take any another magnet, like take a piece of bar magnet like this. So earlier, let's say you have held it like this, but it will be aligning itself in this manner. This will be the north pole, this will be the south pole. Why? Because of the attraction taking place between the unlike poles. North-south attracts, and here also north-south attracts. I hope this should be clear. Okay. If there's a confusion in it, please let me know. Okay. So write down the topic, finding direction, and write down this thing that we can find directions with help of a magnet because of freely suspended magnet always aligns always aligns. So basically write down always points in the north south direction. North south direction. Okay. Like we have the example of a compass, magnetic needle of compass. You guys write down this thing. There's someone on the door. I will be back in a minute. Okay.
Sir, I'm done.
Done. Salman, what about you?
Done, sir.
Done. Good. Next, we're going to learn about how we can also prepare a magnet, make a magnet. Okay, now. So to prepare a magnet, let's say you have taken a rectangular piece of magnet. Let's say you have taken a bar magnet here. Take a bar magnet here. Okay. Now, what we are doing here, okay, we have taken a bar magnet here, and we are placing one of its pole near the edge of the iron here. We are placing it near the one of the edge of the iron, and without lifting the bar magnet, move it along the edge of the iron nail till it reaches the other end. Getting it? Like in this manner. For example, if I were to demonstrate, like I have taken a iron nail in my hand. Hope you guys can see it. It's visible, I think. I have
Yes.
taken a now I have taken a magnet here. So I am going to slide it like this. Over here, I'm going to slide it like this. And then again, I'm going to repeat it like this. Okay. In this manner, I am going to slide it across the iron nail. Got this? It is demarcated by the arrow here also
Yes.
in this. Okay. Now you have to do it for some time. At least you have to repeat this process about 30 to 40 times. How many times? About 30 to 40 times you have to do this. Right now? Now, later on, what we'll observe that it will start to attract tiny pieces of pins like this. You can see this iron nail is now attracting these nails, iron and these tiny pieces of nails here. Okay, pins, I mean to say. Getting it now?
Yes.
Okay, so that is the thing. But this is a temporary magnet. After some time, this will lose its property. Right now, after a few minutes or after a few hours, it will no longer be attracting the pins here. Got this? So that is the steps to make one's own magnet. So write down this one also. The first thing you will be writing that we are going to take a bar magnet or any rectangular piece of magnet. Take a bar magnet. Next, you're going to write down that place it on place it on one of place it on the edge of the iron nail. Place it on the edge of the iron nail and move it along the length of the iron nail till it reaches the other end. Till it reaches the other end. Then lift the magnet and bring the same pole of the magnet to the and place it to the same point of iron nail and repeat the process. The important thing to be considered here now, you don't have to change the poles of the magnet. Like you had taken this pole, both of you pay attention to what I'm showing here. Okay, you had taken this pole of the magnet. Let's say you had taken this pole of the magnet, this one. So you have to take this pole of the magnet only. Like you can't reverse it like this. So you have to take this pole. So you brought it to the corner of the iron nail. You brought it all the you're moving it along the length of the iron nail. Then lift the magnet, and again brought the same pole to this corner and then again slide it. So in this manner you are going to do. Okay, now. So you don't have to change the poles. The pole should be same. Getting both of you now?
Yes, sir.
Okay. And how many times you have to do? You have to repeat this for 30 to 40 times.
20 to 40.
30
30
to
to 40 times.
Huh. Okay, write down this quickly. Today the chapter will be finished. Okay, now it's
Sir,
yes, Salima.
after same point of the iron nail and
Same point of the iron nail and repeat.
okay.
And let me write this once again. And repeat the process. In fact, if you guys have a bar magnet, you can try doing this at home.
Sir, I'm done.
Okay, Salman, you also?
So 2 minutes.
Okay, okay.
Done, sir.
Done? Good. Now, here we are. Here also our aim is to make a magnet, but in a different manner. Okay, na? Like here we are making a magnet with the help of electricity. Okay, now so when we are making the magnet with the help of electricity, then that magnet is called as electromagnet. That is called as electromagnet. Okay, so all of you observe here, we have taken these materials. Okay, now like scissor, copper wire, nail, AA batteries like a small battery, and some paper clips or tape. We can use it or not. Okay, basically we are connecting this copper wire to the terminals of the battery, to the positive and the negative terminals. We have connected it. Okay, with the help of sellotape we can paste it. With the help of sellotape we can connect it properly. Then the copper wire has been rolled on this iron nail. We have rolled it on a iron nail here, right? So as soon as the current will pass in this now, you will observe that it will start to attract these paper clips, right? But as soon as you take out this wire, take out the wire from the connection, as soon as the wire is no longer in connection with the battery, then it will stop attracting the paper clips. So
Yes, sir.
this is acting as a magnet with the help of electricity. Getting it now?
Yes.
Right? So that is the thing
Yes.
about this. Okay, now so in this you have to give the topic of electromagnet. Give the topic electromagnet and just you'll be writing about the definition of electromagnet. Okay, now no need to write the steps of this. Okay, so we'll be writing about the definition of electromagnet. Yes, you guys done?
Sir, done writing electromagnet.
Good. So now in this write that electromagnets electromagnets are electromagnets are a type of magnet that works electromagnets are a type of magnet that works when current flows through it. When current flows through it. Okay.
Sir, done.
So done.
Done. Okay. Also, there are several applications. There are several applications of electromagnet. So uses of electromagnets are as follows. Like electromagnets are used in cranes. Okay, na? It is used in generators, in loudspeakers. Getting it? So there are lots of instruments where it is used. So
Yes, sir.
some of the examples are in cranes to lift off heavy iron objects, iron scrapes. Okay, in doorbells also it is used. There also electromagnets are used. Furthermore, in generators it is used. Electric generators there it is used, and in the motors also it is used. Write down these applications, these uses of electromagnet.
Done.
Both of you?
Yes, sir.
Good. Then another topic is attraction and repulsion among the magnets, which we have learned moments ago. Like opposite or unlike poles, they attract each other. Give the topic and write down these things. Unlike poles or opposite poles attract each other. Right now, like basically the example of this will be like that is north south or
Sir,
south north. Yes.
can we draw the diagram?
Hi, you can draw it, but okay, you can draw it if you wish. You can draw it. Not a big issue. Then like poles, like you have north north or south south. Also, like when we are bringing out the unlike poles together, so attraction is taking place. But the attraction between a magnet and a magnetic material also takes place now, right? Like attraction will also take place. Like instead of bringing another magnet to this magnet, if I were to bring a piece of iron nail, so there also attraction will take place right now. So attraction not only occurs between two magnets,
Yes, sir.
but occurs between a magnet and a magnetic material also. Done.
Yes, sir. Done.
Done. Good. Halima, you also done?
Sir, what?
Okay, okay. Next, we are be learning about like what are the cautions we have to take care of while we are handling with the magnets. Right now, like there are different ways in which magnets can lose their property. Okay, like for example, if you were to drop a magnet from some height now, it will lose its magnetic property. Huh? Or for example, if it were to be heated too much, then also it will lose its property. Getting this now? So if magnets were to be heated, or if it were to be hammered or dropped from some height, they will lose its property. So we have to take care of it. Okay. Also, they are different. Like the magnets, there's a proper manner in which it has to be stored. Okay. Like for example, bar magnets, it should always be kept in pairs. Okay. Now, like how it should be kept, I will be telling you. Done, Halima?
Sir, done.
So the last thing to be discussed in the chapter is the cautions. Okay, now like write down cautions. In the first thing, the magnets can lose their magnetic properties. The magnets
Sir,
can
should we read this?
give the topic. Okay, now so magnets can lose their magnetic properties like if you were to heat it to high temperature, they can lose its property, or if it were to be hammered, they can lose. Getting it now? Or if it were to be repeatedly brought in contact with the like poles of other magnets, meaning that I have two magnets like this. This is the north pole, this is the north pole. If both the magnets with like poles are continuously brought close to each other like this, so it might also result in loss of magnetic property. Getting it now?
Yes, sir. Sometimes even I did that. So
Uh-huh.
after some time, it got like it didn't work.
Okay. Because they will be losing their property in that case. No? So magnets
Yes, sir.
can lose their magnetic properties if they are heated to high temperature, hammered with a piece of hammer if you're going to hammer it continuously, or if or dropped from a height or dropped from a height, or if they are repeatedly brought brought in contact with the like poles of other magnets. So say if
Sir,
then how we should be storing them? Yes.
if we hammer if we hammer the magnet, will the
Mhm.
magnet break?
Obviously the magnet will break, but if you go on to hammer it continuously, then after some time it will lose its property.
Okay, sir.
Okay, no? Or if you were to heat it, it will lose its property. That is the thing. Also, like if they are not stored properly, they will also lose their property if they are not stored. So how to store? The question is how to store the magnet. First of all, write down the first paragraph, then we're going to learn about this, how we have to store the magnet. You guys done writing the first paragraph?
Sir, 2 minutes.
Okay,
Sir, finish.
finished. Good. Okay, so first thing here, not like pay attention here also. Like a bar magnets, like we have taken some bar magnets here. All these are bar magnets. So bar magnets should always be stored in pairs, and they should be stored in such a manner that their opposite poles are in contact with each other. Like the North Pole and the South Pole are in contact
Yes.
with each other. So they should be stored in pairs, and they should be separated by block of wood. Like we are going to place some wood between them. Getting it now? So they should be always separated by some wood. Like they are not in direct contact with each other, but some wood has been placed between them. Okay. So these things here are wood. A block of wood is placed between them
Wood.
so that they don't stick. So block of wood has been placed there, and the unlike poles are facing the same side. Like the unlike poles are facing the same side. Like this is the North Pole, this is the North, this is North, North, and while these are the South Pole. So unlike poles are facing the same side, but they are separated by a wooden block also. Getting it now? That is the thing. Okay.
Yes.
So hope you guys have understood this. Okay. Also, another thing to be kept in mind is that, like, first of all, write down the following thing. Okay, the first thing is that also, like, it's a usual, like we should also keep the magnets away from moisture. Huh? It should be kept away, kept in a cool and dry place. It should not be kept in moisture. Getting it now? So moisture should also be avoided. It should always be stored in pairs, like we have seen here. Okay. Or always, like if you are going to store it in a container, that container should not be made out of iron. Hmm? Also, magnets should always be kept away from any kind of electronics. Like it should be kept away from computers, from from mobiles, from televisions. Getting it now? That is one thing. But write on this thing, like bar magnets should be kept in pairs with kept in pairs with their unlike poles unlike poles facing the same side, and they should be separated with a block of wood. That is one thing. Another thing is that should be it should be kept away from computer, computer, from mobiles and televisions, and televisions. Write down these things. Also, it should be kept away from CDs also, like compact discs. It should be kept away from compact disc also, CD also. Okay. Or if there's any kind of music system, so from that also it should be kept away. Okay. So that is the thing. You guys do let me know once you guys are done.
Done, sir.
Done? Good. Halima, what about you?
Sir, done.
Okay. So will hammering the magnets destroy it or not?
Sir, it will.
Right now? Okay. Also, if I were to, let's say I have broken down a piece of magnet into two with hammer. So it will result into two magnets. Earlier this was
Yes.
north, this was south. Now these two magnets will also be having their own separate poles like this. Getting it now?
Yes, sir.
That is the thing here. Okay. Also, to tell me similar poles of two magnets are attracted or will they be repelling each other?
Sir, repel.
Will be repelling each other. Okay. Okay. Should we heat the magnets?
No.
We should not heat the magnets. Good. Okay. Also, to tell me, like in which direction does freely suspended magnet rest? A freely suspended magnet, in which direction it will be resting?
Sir, north and south.
In the north south directions. Okay, now. So how did we came to know that magnet is useful in the finding direction? Like how did we came to know this? Like basically when it is left freely suspended, it points in the north south direction. So thereby it will be helpful to find the north direction. Okay, that is the thing. Also, you have seen like this magnetic needle. It is always kept closed in this glass. Why it is kept? It is kept in this glass vessel. Why it is not open? Hmm? Why it is not open? So basically to protect it from any external interference by any other
Yes.
by
Like
any
the
other,
wind.
not the wind, like by any other magnetic interference. Like if there is a piece of iron object here, so it might get attracted towards that.
Attracted towards that.
So there will be alteration, like there will be error in finding the direction. Getting it now? So this is
Yes.
to protect it from any external magnetic interference. It is uh, kept in this glass vessel. That is the thing here. Okay now?
Yes.
Okay. So hope you guys have got this. Okay. Also, like you tell me like how the shipments are able to find the direction. Like usually the shipments earlier they used to rely upon the pole star. Now you guys know about the
Yes.
north star.
Yes, sir.
So earlier the sailors used to look at the north star to navigate in the sea. Right now, but now since the invention of the magnetic compass, they were able to look at the direction with the help of the magnetic compass. So they don't need to rely upon that. Okay, now. So
Yes.
hope you guys have understood this thing. Okay, how can we make our own magnet? Yes, Salman and Halima. How can we make a magnet on ourselves? How can we make a magnet?
Sir, we take a magnetic pole and then take uh, take any paper clip or something, and then you just like
Just
move
slide it
it.
along, move it on the
Yes.
on the edge of that. Okay. Okay, got it. Okay, now you guys think of this like magnets comes in different shape and sizes, right? One of that was the circular shape magnet also, like this ring shape magnet, right? Huh? So the question must be arising in our mind, like how will its pole be located? What will be the pole of the magnet? Hmm? Getting it? Like you might be thinking of this. What would be the pole? Like you can find the pole of this magnet, like bar shaped magnet, horseshoe magnet, needle shaped magnet, cylindrical, and even the oval shaped magnet. But when we talk about the poles of a circular magnet, the thing is that circular magnets have the north pole on the top and they have the south pole on the bottom. What I mean to say that
Yes, sir.
in the case of
Sir,
a
it will be the half.
in that manner, okay, na? So they are located on opposite faces of the magnet. Like the one side is like if I were to have a like let's say this is a circular magnet. So one side will be positive. I mean to say one side is north pole, another side is
North pole
south
and
pole.
south pole.
Okay, na? So that is the thing. Okay, so
Yes,
that is the location of the poles of this circular magnet. Okay, hope you guys have understood this thing. Okay.
yes,
Okay, there was another question in my mind, like um, mm, like say that you have a U-shaped magnet. We had learned about storage of a bar-shaped magnet, no? How we can store a bar-shaped magnet.
yes.
But what if I were to provide you with a U-shaped magnet? Then how are we going to store that magnet? Hmm? A
Sir,
horseshoe magnet,
you
basically.
opposite side. Like first one will be like a U shape, and the next one will be the like opposite of.
Okay. There also we're going to place it in pairs, right?
Yes,
Very good. So like this one, let us say that this one is the north pole, this is the south pole. So here also we are going to place some wooden structure, wooden block, and then we are going
yes,
to place another horseshoe shaped magnet here like this, and this should be north, this should be south, right now. So
yes, sir.
we are going to store, first of all, we would be storing it in a wooden box, right? And we will store it in pairs. Okay, so we can keep them in pairs, and their opposite poles are facing in the same direction. Okay, now, and we are separating them with a wooden block. Okay.
Yes, sir.
Also, it is important that at the poles now we place a soft magnet. At the poles we place a soft magnet. Getting it? Like at the poles here we'll be
Sir,
placing a.
soft magnet means like
Mhm. Basically
example.
magnets are of two types now, like they are soft magnet and hard magnets. Like in the soft magnet are those kind of magnet which have low carbon in them. Like magnets would be those that they can be like for example they are the magnets that is used in electric motors and the generators. Hmm? And
Yes, sir.
they can be easily demagnetized, meaning that if they were to be dropped off some height now, they will easily lose their magnetic property. If they are hammered, they will easily lose
Okay.
their property. Getting my point, Salman and
Yes,
Halima? The soft magnets are those magnets now that will easily lose their magnetic property, right now. That is the thing. Also, the way how they are made now, like they can be easily demagnetized, and also they can be magnetized again also. That is the case about the soft magnet. Hmm. But talking about the hard magnets, so hard magnets are also known as permanent magnet. So one more thing to be noted down is that you can write down this thing also, types of magnet. In this you can just be write down, you have soft magnet. Actually both of you write down this thing, soft
and
magnet,
hard
another one
magnet.
is hard magnet. Hard magnet is also called as permanent magnet. Permanent magnet. Okay, now while it can be called as like it can be called as temporary magnet, but like it can, like we can call this as a temporary magnet in this manner, like it can easily lose its property, easily lose its magnetic property if you were to heat it, or if you were to drop it from some height. That is the
Done,
thing
sir.
here. Done now? So this is the manner how we're going to store this U-shaped magnet. First of all, it should be kept in a wooden box, and the opposite poles should be facing each other. So hope that is clear. Okay. If there's any question from the chapter, please do let me know, because here we have finished the chapter. Yes. If there's question in it, please let me know. Halima and Salman, do you guys have any questions from this chapter? Yes. Okay, so how many poles are there in a magnet? 2, 3, 4, how many poles?
Sir, can you just go to example?
Can I just?
Sir, 2 poles.
2 poles are there, huh?
Sir, can you just go to the examples of magnet?
The last line, it's inaudible. Halima, what did you say? Repeat again.
Sir, can you just go to the examples of magnet? Like the U,
Okay,
the
the
horse.
shapes of the magnet you're talking about. Different
Yes.
shapes of magnet. Yeah, bar-shaped magnet, horseshoe magnet, needle magnet.
Sir,
Mhm.
in the cylindrical magnet,
Hmm.
how are we supposed to identify? Like, it's the same as bar magnet only?
No. Cylindrical. You're talking about the poles or the shape?
Sir, the poles.
Talking about poles of cylindrical magnet now.
Yes.
Okay, so talking about the poles of the cylindrical magnet, it will also have 2 poles, basically one north and south pole, right? And
Yeah.
regardless of the shape here, this will also be on the opposite ends. Like this is north, this is south, this is south, this is north. Just like
Okay,
the
sir.
bar magnet. Okay, just like the bar magnet you have seen. Okay, so hope you guys have understood this. Okay, if there's any
Yes.
questions left from the chapter, please let me know. Otherwise, in the next class, we'll be taking up a new chapter. Okay. And Halima, I suppose your syllabus for the half yearly exam has been finished, right?